This video is again on piecewise functions. We're dealing with three pieces or three functions and pieces of those functions with regards to the restrictions. We have to be careful on those. I'll be graphing these in three different colors to be able to see them. So I'm going to graph my first one in green, my second one in pink, and my third one in blue. So my first one, I'm going to graph my calculator. I'm going to go to my calculator and clear it out. I'm going to type in 2. Now I go to my table because I don't want to see the actual graph. I don't want to see the graph. I just want to look at my table. My first x value has to be at 5. So I'm going to go down. Here's 5. And I can graph that first coordinate, 5, 2, and it will be solid. So I need to make sure I have my x and my y on my axis. So x and y. Go ahead and put them on both. My first coordinate again is 5, 2. So 5, 2, and it is solid. And I want all of the x values that are bigger than 5. So I'm going to go to 6, which is also at 6, 2. Then 7, 2, 8, 2, 9, 2, 10, 2. We can keep going. All of those will keep going that way. The next one in pink, I'm going to go to my y equals and clear that out and type in negative 2x. And I have to go between negative 2 and positive 3. So I'm going to go to my table. So I want negative 2 to be my very top one. That's my first point I can graph, negative 2, 4. And since negative 2 is solid, this coordinate will be solid. So negative 2, positive 4 will be solid. But then I want to go to 3. I'm going to go ahead and put my stopping point of 3. So my coordinate is 3, negative 6, but it has to be open. So I have positive 3, negative 6. It has to be open there, though. So I can graph all the coordinates in between those. So negative 1, 2, 0, 0, 1, negative 2, 2, negative 4, and I already have the 3, negative 6, so that's as far as I can go. So I can graph these and connect them. And then for the blue, I'm going to go to my y equals, clear it out, 2 minus x squared. And I'm going to go to my table. My first coordinate is at x at negative 2. So my x of negative 2 here is going to be open. So negative 2 is my first coordinate. Negative 2 is open. And I need all of the x values that are smaller than negative 2. So I'm going to go up here to negative 3, negative 7. And this can be solid because now I can have them solid. The next one I can do is negative 4, negative 14, which is going to be kind of down here. I'm not going to be able to graph that, so I'm just going to kind of go here. It's going to just keep going. And I can see that these numbers will keep going down, so I'm just going to put an arrow down. This will keep going down. So if I did look at this graph, I need to know if that will go down or if it's going to come back up. If I look at the graph of this, this was your vertex way over here, so this one will have to keep going down. So yes, it will keep going down. So now we look at our domain and range. So domain, we look at the left, so your leftmost point is the arrow, your rightmost point is an arrow. So we will have infinities. So it will start at negative infinity. So we're going from the blue arrow to that green arrow. So to the right, 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 stop. Since I want to keep going right, I have to see if I can jump up or down to something solid because this is not solid. So if I can jump up to this solid point, I'm good. So I can keep going to the right on the pink, to the right, 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 stop. I want to try and keep going right, but so I have to jump up and down to something solid. There's nothing solid on here, so that means I actually have to stop here. So that's going to stop at that positive 3 on the x. It's going to have an open bracket because that was an open circle. That means that I have to start back over on the green. So I have to union. Now I can start at the next x value. So the 3 wasn't hit, the 4 wasn't hit, but the 5 is. So this 5 value is where we're starting, and it's closed. And then I can keep going to the right forever. So that will give me to that positive infinity. for the range, we do, your smallest y value is this blue arrow, and our highest y value is this pink coordinate. So we have this blue arrow going up, 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 stop, because it's not solid. I have to try and jump left or right so I can continue to something solid, and I can on the pink. Then I can keep going up to this top pink one, so there's no actual break in between them. So we actually have from negative infinity, and there's no break, so we don't have to unite them. It goes up to that positive 4, and it stops at that positive 4. This next example, we only have 2, so I'm going to use pink and blue. To the first one, go into my calculator, y equals, clear it out. I have x plus 5. I'm going to go to my table. My first coordinate has to be the x value of negative 2, so I'm going to scroll to that x of negative 2. So my first coordinate is at negative 2, 3, and it needs to be open. So negative 2, positive 3, right here. And it says x is smaller than negative 2, so I want the negative 3, the negative 4. So all of these coordinates, I want to graph all of these. So that's negative 3, 2, negative 4, 1, and then I keep going. So that'd be negative 5, 0, negative 6, negative 1, negative 7, negative 2, negative 8, negative 3, negative 9, negative 4, and negative 10, negative 5. So I can connect all of these. And then I can go do my blue. So y equals clear. I'm going to type in x squared plus 2x plus 3. I'm going to go to my table. My first coordinate, my x value is that negative 2, so I'm going to come down here to that negative 2, and it needs to be closed. So negative 2, 3 is my first coordinate. Negative 2, 3, and it's going to be closed here. So again, this is still a function because the pink was open and the blue was closed, so I don't have two closed parts on there. Now we want all the numbers that are bigger than that, so we want to go to negative 1, 2, then 0, 3, 1, 6, 2, 11. So I can go a little off the graph here, and then I can connect these. So it's going to go down and then back up. So this is a parabola, and it will keep going up. And that tells us that that's actually going to be our vertex. And we can look at our graph of that one just to make sure, yes, that is where it loops, and then it will keep going up. So for our domain, this arrow is pointing left, that arrow is pointing right. So we will have negative infinity and positive infinity. So going from arrow to arrow, right, 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 stop at the pink because it was open, but there is a solid blue already there, so I don't actually have to stop. So I can keep going to the right, to the right, to the right, to the arrow. So there's no break, so it goes from negative infinity to positive infinity. The range, pointing down, pointing up, so we're going to have negative infinity and positive infinity. So from pink arrow to blue arrow, up, 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 stop. Again, because it was the pink open, but there's a blue closed, so it's still good. Then I can keep going on here. This is going to go down, but it'll keep going up. So actually from here, if I want to keep going up, I jump from left to right. There's something solid right here. So I wanted to keep going up. I didn't want to backtrack and go down. So if I'm here, it's solid here. I need to find, because I can't keep going up from here, I jump left or right to something else. And here it is. And I can keep going up from here. So I never actually have to stop and break because I was able to jump to something else solid without hitting a gap on my range.